Next, we're going to take a look at conditionals. If something happens, then this other thing happens. Parents use these all the time, right? We use these all the time as humans. If you do this for me, I'll do this for you. If this happens, then this other thing happens, right? If I get my homework done, then I can hang out tonight. So if something, we call this something a hypothesis. Then the other thing happens. That's called the conclusion. One of the things you want to be careful of is hidden conditionals. Hidden conditionals are something like a number is even if it is divisible by 2. What's the hypothesis there? The number is even if it's divisible by 2. Isn't this the thing that has to happen, right? This is the hypothesis. If the number is divisible by 2, then the number is even. So this is my hypothesis. It's really saying if this happens, then this happens. This is called a hidden conditional, hypothesis, conclusion. And you want to be careful about these because if you switch the order, it makes a big difference to the meaning. Okay? So the conditional P arrow Q is false only when, well, let's talk about when is this thing false. Think about a conditional as a promise. If someone makes a promise to you that if you do something, they'll do something else, when would you call them a liar? Well, in order for you to call them a liar, 2 things have to happen. You have to do what you were supposed to do, and then they have to not do what they were supposed to do. I'll give you an example. Parents say to you, listen, if you get good grades, then we'll buy you a new computer. It's like a good deal. Work hard, get good grades, get a new computer. When can you call your parents a liar? Only if one thing happens. You get good grades, right? You've got to do your end of this thing. You've got to bring home the grades. But then you get to turn to them and say, hey, Mom and Dad, where's my computer? If they don't deliver, that's when you get to call them a liar, right? So the only time this statement is false is only false when you have a lie. What does a lie look like? You do what you're supposed to do. True hypothesis. But you do not get what you're supposed to get. False conclusion. You get the grades, you do not get the computer. Any other time, this is a any time this is a true statement. These are always going to be true, except when it's a lie. True or false. So with that in mind, let's take a look at a couple examples here. Conditional PRQ is false only when, well, that's what we just talked about. You do what you're supposed to do, you do not get what you are supposed to get. You get the grades, you don't get the computer. That was a lie, and we call it such. When the conclusion is true, so the conclusion is true, then the whole thing must be what? Well, let's just think about this a minute. If the conclusion is true, the hypothesis is either true or false, right? Okay. So let's say the hypothesis is true. You get good grades and you get the computer. True conditional statement? Yeah, definitely. That's good. What about the other way? If the hypothesis is false, but you still get the computer. So no good grades, but computer anyway. The whole statement's true. Because again, you can't call them a liar. We just didn't talk about what would happen if you don't get good grades, right? We talked about what happened if you get good grades. If you don't, we never said. In this case, turns out you got the computer anyway. So whether the hypothesis is false or not, if the conclusion is true, this has to be a true statement. Must be. What if the hypothesis is false? Well, if the hypothesis is false, P or Q must be. So this means you didn't get the good grades. But then we don't know if you're going to get the computer or not. You didn't get the good grades. You get the computer. Well, you don't get the computer. Either way, we don't even really matter. Here's what's going on. The deal was if you get good grades, then something happens. You didn't get good grades. So the deal is off. It doesn't matter what happens on this end. The person you made that deal with can give you the computer or not give you the computer. It's up to them because the deal is what happens if you get good grades. Since you didn't get the good grades, you're never going to know if they would have upheld the deal. So you have to give them the benefit of the doubt. Anytime the hypothesis is false, anytime, the whole statement is true. Right? It's like if I say to you, like I did on the quiz, if the moon is made of cheese, then something happens. Well, everything I say after the moon is made of cheese doesn't matter. because that's a false hypothesis. So whatever I claim is going to happen, the whole statement is true. It just doesn't matter. Last one, if the hypothesis is true and the conditional is true, then the conclusion must be, well, if the whole thing is true and the conclusion is true. So that means we have true hypothesis, arrow, we don't know, right? It's asking us, what does the conclusion have to be? Well, can it be false if the whole conditional is true? Wow. If that's false, what does it make the statement? A lie. That would be true, arrow, false, and the whole thing would have worked. So this must be true. The conclusion has to be true. Okay? Conditionals are one of the most important and easiest to get tripped up on. Please make sure you remember, they're always going to be true except when they're a lie. If you do what you're supposed to do, you do not get what you're supposed to get. Any other time it's true. In that one case, you do what you're supposed to, you do not get what you're supposed to. That is a lie, and that is the only time it's false. Conditionals. Well, conditional is one way, then we have biconditional. Both directions. P, if and only if Q, right? So P, if and only if Q. That's how you read this. If and only if, or double arrows. We could talk about this one a lot, but for the sake of the podcast, I'm going to leave it very straightforward and simple. When is this statement true? It is true when both P and Q have the same truth value. This is true when both are true, or both are false. Either one works. Here is why. Very briefly. P, if and only if Q, means if you have P, then you have Q, and if you have Q, then you have P. If these are all true, everything's fine. The whole thing works. If they're all false, it works too. False, arrow, false, that's a true statement, right? That's, if the moon is made of cheese, then something. I don't care. The moon's not made of cheese, so it's true conditional. But if they're different truth values, if P is true and Q is false, then that one's a lie. If it's the other way around, if Q is true and P is false, well, then this one is a lie, right? So if they're different, one of those two sides is going to be false. And if one side is false, the whole thing's going to come down because it's an end statement. So the key here is they have to be the same. If they're both true or both false, you're in good shape. Different truth values, not okay. Alright, last thing I want to talk about is inverse, converse, contrapositive. That's a blank screen. Inverse. Well, if you have P, arrow, Q, to get an inverse, you simply negate both terms. You negate. So you end up with not P, arrow, not Q. It's just that simple. What if you started with something that was already negated? Right? So if you started with not P, arrow, Q, no problem. Just follow the rules. You negate both sides. What's the negation of not P? Not P, which is P. So we have P, arrow, not Q. That's all you do. That's inverse. Converse is when we switch. Okay? So the rule here is we switch the hypothesis and the conclusion. So if I start with P, arrow, Q, I just flip them, and I get Q, arrow, P. Whatever's in the beginning, put it at the end. Whatever's at the end, put it to the beginning. Last thing we have, contrapositive. This one is important. What's the big deal here? Contrapositive is always what to the original? Logically equivalent. Contrapositive is always logically equivalent. This is huge. It's logically equivalent means it has the same truth value. In other words, you're saying the same thing, but in a different way. In proof, we use this a lot to kind of get around something that's difficult to prove. So, if these are always logically equivalent, it allows us another way to get it a proof. How do we get a contrapositive? We switch and negate. We do both of the things for the inverse and converse. So to get this, we switch and negate. So if I start with P, arrow, Q, I switch, I negate, I end up with not Q, arrow, not P. What if I start off with something a little bit more convoluted? Let's say I have not P, arrow, Q. That's fine. I just have to follow the rules. I'm going to switch them, I'm going to negate them. That means my old conclusion is going to go to the front, but negated. So Q becomes not Q. I'll do this one in red. Arrow. My hypothesis goes to the end and gets negated. Negation of not P is not P, which is P. So I have not Q, arrow P. That's my contrapositive. These are exactly the same statement. Remember in class when we did if it rains, then my shoes get wet? That's the same as saying if my shoes aren't wet, then it must not have rained. We switch and negate, we get the contrapositive logically equivalent. Always the same as the original. Okay, so that's it for basic logic review. I think I might have ended up splitting this into 2 videos. If you stay tuned for the 3rd video, in that case, you're going to get to see some logic proofs. We're going to go over the laws that are important and do 2 examples with you. Thanks as always for watching. If you have any questions or feedback, you can grab me in class or send me an email. You can find the email on the website. Have a great day and thanks for watching.